All right, welcome to the Explainer. So, what if a government budget, what if it could be as reliable and predictable as, say, the laws of physics? Sounds a bit out there, right? Well, today we're going to break down a piece of tech that's trying to do exactly that. It's all about bringing mathematical certainty into the super messy world of finance. So let's dive in and see how this thing actually works.
Okay, so here's a classic problem, right? How do you explain a genuinely revolutionary piece of tech to a world-class expert? I mean, someone who's seen it all. You can't just walk in there throwing around a bunch of buzzwords. If you really want to get their attention, you've got to speak their language.
And that's the key. You have to speak their language. So let's say you're talking to someone like a federal budget director. You're not going to start off with crypto or blockchain. No way. You're going to talk about the things they care about: fiscal control, audit traceability, integrity. You frame the whole idea in the terms they already live and breathe every single day.
Okay, but before we get to the cool solution, we really need to wrap our heads around the problem it's built to solve. And it's a really subtle but massive problem. It's this hidden flaw that exists in so many large-scale accounting systems, something called financial drift and leakage.
So what in the world is drift? Well, picture a massive financial system. We're talking huge government budgets, multinational corporations, that kind of scale. In systems that big, tiny, and I mean tiny, seemingly insignificant errors start to pile up. It's a concept that goes by a couple of names, like rounding drift or cumulative rounding leakage.
Now, on its own, a single rounding error, a tiny fraction of a cent, it's literally nothing. It's dust. But, and this is the kicker, when you take that microscopic error and you multiply it by millions or even billions of transactions over time, well, the impact becomes absolutely shocking.
We're talking about this drift leading to millions, sometimes even tens of millions of dollars in what are called audit mismatches. It's like this phantom leakage, The money that was allocated on paper doesn't perfectly line up with what was actually spent. And it's all because of those tiny, pesky fractional cents just piling up one after another.
So the big question is, how do you build a system that's just completely immune to this kind of financial drift? Well, the solution lies in creating something called a deterministic engine. And that's just a fancy way of saying it's a system that enforces financial rules with absolute, undeniable mathematical certainty.
And here it is, the deterministic budget execution engine. Now let's be super clear. This is not a new payment app. It's not another cryptocurrency. You should think of it more like a constitutional-grade control system. Its one and only job is to guarantee a mathematically perfect distribution of funds, create a flawless audit trail, and, this is the most important part, have absolutely zero rounding drift.
So this whole engine is built on 6 core components that all work together to make these guarantees possible. You've got controlled appropriations to set those hard limits, deterministic earned accrual to release funds right on schedule, allocation without rounding error, which is pretty self-explanatory. Then you have replay resistance for that unhackable audit trail, an atomic settlement guarantee for transactions, and finally, cross-system determinism to keep everything consistent. Let's dig into a couple of these a little more closely.
All right, first up, controlled appropriations. This is all about enforcing hard budget ceilings right at the protocol level. So think about it this way. The budget constraints you set aren't just a suggestion sitting in some spreadsheet that someone could maybe ignore. Nope, they are unbreakable rules that are literally baked into the system's code. It means funds can never, and I mean never, exceed the authorized ceiling. It's impossible.
Okay, let's jump ahead to number 3, allocation without rounding error. Because this is the one that directly tackles that financial drift problem we talked about. So how does it do it? Well, instead of using complex decimal points, the floating point numbers that cause all those tiny rounding errors, the system uses only whole numbers for its math, integer only. Any leftover remainder is handled in a totally predictable, predefined way. And just like that, you've completely eliminated the possibility of that fractional cent drift. No more audit mismatches between the different ledgers.
And this is where the really cool cryptographic security kicks in. Every single financial event, every state transition, is mathematically chained to the one that came before it. What this does is create a completely unchangeable or immutable audit log. This is that replay resistance feature. It means you can't secretly go back and modify old records or try to rerun a past payment without breaking the entire chain. It's kind of like a ledger where every new entry puts a mathematical seal on the one before it, locking it in forever.
So what does all this add up to in the real world? What do you actually get? Well, what you get are ironclad guarantees. This is the big leap, you know? It's what moves the whole idea of a budget from the wishy-washy world of spreadsheets into the solid, unshakable world of mathematical proof.
And this really shows you the fundamental difference in reliability. You know, in traditional systems, rounding errors pile up, logs can be messed with, but with this engine, there's absolutely no rounding drift. The audit log is set in stone. And settlements are atomic, which just means they're all or nothing. The transaction either goes through perfectly and completely, or it doesn't happen at all. There's no in between.
And I want to stress this again. These aren't just goals or, best practices. They are mathematically enforced guarantees. Total spending can never go over what's authorized. The allocations must always add up perfectly, and the financial history cannot be silently changed, period. It's a system that's literally built on a foundation of certainty. There's a quote from the source material that just perfectly nails the whole idea of this engine. It says it behaves more like a constitutional court than a spreadsheet. And that's it, right there. It's not just a calculator crunching numbers, it's a decider. It's impartially enforcing the rules it was given without any wiggle room. Now, to really get the full picture here, it's super important to understand not just what this engine does, but also what it doesn't do. And this is where we get to that big idea, seeing it as a kind of constitution for money.
See, the engine is fundamentally apolitical. It has no opinions. It doesn't decide on policy. It's not setting tax rates. It doesn't determine who gets what slice of the pie. All of that stuff is decided by people. The engine is just a completely neutral enforcer of the rules that we give it.
So at the end of the day, this thing is a settlement constitution. It's not a fiscal policy engine. Humans, we set the policy. We decide the what and the why. The engine's only job is to execute that policy, with perfect, mathematically guaranteed fidelity. It just enforces the math. That's it. Nothing more.
And that really leaves us with a pretty profound question to chew on. What if our budgets, the very foundation of public finance, weren't just policy suggestions typed into a spreadsheet, but were instead mathematically provable laws, enforced with absolute, unquestionable integrity?